Alright, in this tutorial we are going to write an equation of a line in slope-intercept form, but instead of given a graph or a linear function that's plotted out in an xy coordinate grid, you're going to be given just a couple pieces of information about the function. So remember, the two things that you need in order to write an equation of a line in slope-intercept form are its slope and its y-intercept. So our whole goal is to make sure that we have these two things present before we can write it into y equals mx plus b form. Once we can get those two, then we can write it in our y equals mx plus b form, or slope-intercept. So a line that includes the point 0, 3 has a slope of 3. What is its equation in slope-intercept form? This one's pretty easy because we are given straight up its slope is equal to 3, so that is our m. In this coordinate grid, our xy coordinate, 0, 3, we have to determine if this is an adequate point for us to use for our y-intercept. Remember, the y-intercept is the point where the graph crosses the x-axis, or crosses the y-axis. Which means that every single line that crosses the y-intercept at the y-axis will have an x value equal to 0 every single time. So since this point already has that x equals 0, that means that this value of 3 is going to be set equal to our b. So all we're going to do is take these two numbers, plug them into our y equals mx plus b. And that is our slope-intercept form. So with the second one, we're given a line that passes through 2 points, negative 7, 7, and 13, negative 3. What is its equation in slope-intercept form? So the two things that we need are slope and y-intercept. We don't have a slope, so we have to figure that out. We are given 2 points, which means we can use our slope formula in order to calculate the slope between these 2 points. So the slope is going to be equal to y2 minus y1, the change in y, over the change in our x's, x2 minus x1. And now we're just going to plug in our values. y2 is negative 13, y1 is 7, x2 is 13, x1 is negative 7. And we're going to make sure that it's subtract between both, bringing down our negatives when necessary. Negative 13 minus 7. These two numbers have the same sign, so you add 13 plus 7 is 20, and you keep the sign of both of the numbers, which is a negative. 13 minus negative 7, it's double negative, so you change it to positive, over 20. And when you simplify, these two things reduce to having a slope of negative 1. So I'm going to label that as my m and save it for later. So now we have to figure out if either one of these points are sufficient to be considered for our y-intercept. Well, none of them have an x value of 0. So what we need to do is plug all of this information into a generic y equals mx plus b, and we're going to calculate the b, or solve for b, in the slope-intercept form. The values we plug in for x and y could be any one of these 2 points, whichever one that you feel like is easiest. The 7s are smaller, so that's what I'm going to plug in for my x and plug in for my y, and then your m gets plugged in from the negative 1. So y is now 7, m is negative 1, x is negative 7, and b is what we're trying to solve for, so this is the one that stays in the variable form. Negative 1 times negative 7 is 7. We are going to subtract 7 on both sides, and we are left with b equals to 0. So these are the two values that we use to plug into our equation. Y equals mx plus b, which is 0. I'm going to erase that. Now you could circle this and call it good. I do want you to start kind of eliminating some things that are not necessary. So you do not need to put the negative 1 in front of the x. You could just say negative x because there are negative 1 of those. And you do not have to write anything added to 0 because it does not change the value of your equation. Since that little gap is blank where your b would be 0.